Good day everyone, my name is Carl Francis Filipino and I am a grade 12 student from Mater Dei Academy. So for today's video is about P6. So our topic for today is the scalar and vector. So we're gonna apply our knowledge and what we learned about this topic. So but before we proceed on applying it through problem solving, I just want a quick review for you who's watching right now for scalar and vector quantities. So first is scalar quantities. What is scalar quantity? So it is defined as the physical quantity that has only magnitude. So what is magnitude? This is the size or the measure only. So that is for scalar quantity. So next is, it also refers to the magnitude, size, and amount of something without the need of its direction. So you don't need the direction. So in the other hand, vector quantities. So for vector that has both magnitude and direction, it was usually represented as arrows. So the length of the arrow indicates the magnitude of the vector. Thus, the direction of the arrow indicates the direction of the vector. Okay, clear? So here's the example of scalar and quantities. So as a scalar has only a magnitude. So scalar has the length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work, power. So that is for the scalar. It has only the magnitude. So with the other hand again, vector quantities. So for the vector quantities, it has the magnitude and direction. So for the vector quantities, it has the displacement, velocity, acceleration, momentum, force, lift, drag, thrust, and weight. And that is, it has all of the magnitude and also has a direction. So as for the quick review, I hope you learn or refresh something in your mind. So now we are proceeding to the main topic, the resultant vector. So what is the resultant vector? This is the vector of sum of two or more vectors. So it is the result of adding two or more vectors together, okay? So by solving resultant vectors, we prepared two methods today, the graphical and component method, okay? So the first method that we were using was the graphical method. It called the other term of head to tail method. It is the graphical way to add the vectors. So the second method is more accurate, the component method. It is a standard way to add the vectors. This is most likely to be the most accurate than graphical method because this is the exact way of adding it. Before we proceed to the problem, I'm gonna need some materials. So first one is a ruler for graphical method, and also this one, protractor for graphical method. So you're gonna need two different shades of ball pen, and I'll explain that to you later. For the component method, you only need a ball pen, ruler for some instances, and most especially the calculator because we will solve in component method using by this. So proceeding to the problem, here is the problem that we need to solve by graphical and component method. Take a look. Sander, Jazz, Leia, Rob, and Martin went to a football field to practice their skills in throwing a football. The 5 players throws the ball with a different force and direction. Determine the combined direction and force. Find the resultant vector. 1 is equivalent to 1 centimeter. Sander has 5.5 Newton at west. Jazz has 8 Newton at 35 degrees northwest. Leia has 6 Newton at south. Rob has 4.5 Newton at 45 degrees southwest. Martin has 9 Newton at 10 degrees southeast. After we discuss the problem which we are solving with the graphical and component method of the resultant vector, the first thing that we need to know before we start solving is the problem given and this map. This is where you can find the direction that you needed when in terms of graphing. Okay, so but first let me repeat the materials need to use in graphical method. The ruler, of course, this protractor, and the two different shade of ball pen for us not to be lito or it got messed up. So let's proceed. So for here, the problem determine the combined distance and force of the problem. So Sander has the 5.5 Newton at west. Jazz has 8 Newton at 35 degrees northwest. Lei has 6 Newton at south. Rov 4.5 Newton at 45 degrees southwest. And Martin 9 Newton at 10 degrees southeast. So that how they threw the ball, the direction and the force they gave to the ball. So here at the very bottom part, as you can see, this is the map where you can see the north, the direction overall. So here north, this is going upward, and south going downward. East is going to the right and west is going to the left. So this will be the thing that you need when in terms of graphing. So for the northeast, northwest, southwest, and southeast, you can see that there's a quadrant. So this is the quadrant 1 for northeast, quadrant 2 for northwest, quadrant 3 for southwest, and quadrant 4 for southeast. So let's proceed to graph. So as the basic of graphing method, we need to find first the direction. So it is in the west. So dito. So meron na tayo dito yung so we have this cross, so the XY axis. So here we can see that the west is from the left. So we need to mark it here. So we're gonna use this blue ball pen to determine the vector. Okay, so at the 5.5 Newton, so this is how long. So when it comes, as you can see pala, from this, west and south don't have actually the degrees or the direction, but as we can see here, this is very common. Well, when it comes to west and east, it is 0 because it belong to the x-axis, and north and south is belong to the y-axis. So from y-axis, it is absolutely 90 degrees, and x-axis is absolutely 0 degrees. Okay, so here west and south don't have degrees, because when on the other hand, northeast, northwest, southwest, and southeast can be possibly from a different angle, like this, because it's very expandable. As you can see, it's very wide. So there's a wide variation of angles, as you can see in the protractor. So let's proceed. So the 5.5 Newton rather. So that is how long. So at the west, we don't need protractor because it has the default direction. So Newton is equivalent to centimeter, as you can see in the
ruler, we have the centimeter. So be careful when um, tracing. Yung as possible as you can, you need to um, be careful that needed to be straight. Okay, so yan. So from starting 0, we need to find the 5.5. So mark it. So 5, here's the 5 centimeter, and this is the the 0.5. So mark it. So trace it for you to get the vector. So we need to trace that. So this is the first vector, which Sander threw the ball from 5.5 Newton, and at the west. So this is the west part. So make it marked there. So we need to draw again a x and y axis because it is needed for us to have another reference for the next vector. Okay, so yan. So adjust natin ng konti kasi medyo mahirap, maliit lang yung space natin. Yeah. So ayan. So again, here is the first vector, which is 5.5 Newton, or in converted to 5.5 centimeter. So to the next, as just is 8 Newton at 35 degrees northwest. So where is the northwest? So here in the quadrant 2. So as we can see, the new x and y axis is here. So this part. So we need the protractor because northwest is at the 35 degrees. So we need to find 35 degrees. So yan. This is the proper way to use protractor. So yeah. And this is the protractor. So it is from the quadrant 2, so it will begin here from the 0. It will start here. So let's count from this part. This is 35 degrees, as you can see, between the 30 and 40 degrees. So mark, trace it. Okay, here you go. Mark and leave them for a while. Then after you get the direction, we need to know the distance or the force implemented. So at the centimeter, 8. So as you can see, this is the mark. So we need to trace it and find the 8 centimeter. So here's your ruler. We need to find the direction. So yeah, it's very hard to trace because I have a small space here. So yeah, bear with me guys. So as you can see, mark it from 8 to 0. So that is the second vector, and trace it downward for you to have the second vector. So this is exactly the 8 centimeter with a 35 degrees northwest. So proceed. We need to get another x and y axis. So we're gonna need to use this. After this, we will give this label, but first we need to grab this. So it's not nakakalito because you have the reference here. So yeah. So again, adjust natin. Yeah. Make sure na pantay. It is straight. Yeah. So this is the second one. So yeah, medyo hindi pantay, so it's okay. So at least meron tayong mark. So at least we have the mark here, rather. So yeah. So from here, we need the downward part. So because it is in the south, so downward. So here is the south in the x and y axis. And we need to find the centimeter or the Newton implemented. So from starting here, we need to find this spot because this is the last quadrant. So gonna use the blue ball pen again for us to see the vector properly and to label it properly. Okay, so 6, mark it here, 6. So after you mark it, you can trace it down. Okay, so here is the third vector. Okay, so for the third vector, we're gonna need to trace another x and y axis. So yeah, here is the x and y axis. And for the fourth one, is 4.5 north and Newton at the 45 degrees southwest. So southwest in the quadrant A. So the direction is from here. We need to use again protractor to have this. So babaliktarin nyo lang, hindi like that. So this way, mali ako. Yan. Binaligtad natin. So from the quadrant E, find the 0 again. So at the 45 degrees. So between 40 and 50 degrees. So as we can see here, mark it here. And there you go. 4.5. So at the centimeter, we need to convert it 4.5. So again, I'm gonna need to use this 4.5. Sometimes you don't need to mark it when it's basically here in the centimeter, and when it not going too long. Okay, so again, so don't mind this dot because this is only the reference for the excuse me, for the distance. So again, we need this we need again another x and y axis to get the last vector. So again, yan. Sorry po, hindi medyo pantay. I'm not good at this, but I'm trying my best. Yeah. So here, and we need to pin that, and for that part, the last Martin get that 9 Newton force and at that 10 degrees. So as we can see, here is a protractor again. So ayan, pantayin lang natin kasi medyo hindi pantay talaga. So ayan, we can mark it here. So 10 degrees. So that's the point, as you can see. So pull out your ruler again and have the last vector. So as you can see, 9 Newton to centimeter. So yan, medyo lumagpas siya kasi medyo pangit yung table natin. So hanggang dyan lang talaga siya. So hanggang dito lang, lakihan na natin. And put this an arrow. Yan. So yeah. And to find the resultant vector, this is very important. So so make sure this is visible always. So this is accurate. So for this x and y axis, we need to trace here at the southwest for us to get the last vector. And for that, if we trace that from here to here, we will get the resultant vector. Okay, so we need to find centimeters. So yeah, so once again, trace it from point to point. So here it is exactly 8.5. 8.5. So this is 8.5, okay? 8.5 here in centimeter. So 8.5. That is the Newton. So 8.5 N. For us to know the distance, we need again the protractor, so that we will see what is the degrees, because it is from the quadrant 3, okay, from the southwest. So once again, balik ta rin, put it down here, find the 0, because, and you will start here because it's the southwest. Okay, we'll start here. So let's find where this belong. Okay, so to be exact is 42 degrees. 42 degrees. In southwest. So please put the label here. So for here, 5.5. For Xander, 5.5 N. Xander. So for here, Jazz is 8. So for here is Leia is 6 south, 6 Newton. So for here is for Rob. Rob is 4.5 Newton. So here is for Martin is 9 Newton. So for this, you can see, you can put the angle here. So for this, it's not, you cannot put angle here because it's absolutely 0. So for this is 35 degrees. For this is no. There's no angle here. It's my bad. So for this, it's 45 degrees. 45 degrees, and for this is 10 degrees. So this is the resultant vector. Ayan. So here you go. So this is the graphical method. So I will put a picture here for you to see the scan photo of this graphical method. After we solve the graphical method, we are now proceeding to the accurate part of this resultant vector, the component method. So before that, the materials here is pen and the calculator. For the calculator, you need to change the mode into the radian to degrees, because degrees has the most accurate answer when it comes to solving this method. So I wrote down different methods, different formulas that we are needing to this method, and they didn't remove the sheet of their graphical method because here are the reference for us to solve this component method. So, we need to find the x and y. But, before finding that, we need to write down the signs. So, as you can see here, at the first sander is 0 degrees. Because it is here lying in the x-axis west. So, for the west, it is 5.5. So, here, 5.5 siya. So, it's gonna be negative because here is the positive part in y-axis and here is the negative part. So, dito, negative siya. And for the y, it's not, don't have sign because it is 0. And for the jazz is northwest, so it is in the quadrant 2. The sign here is negative positive. Negative positive. And the next part is Leia, which is in the south here. So south, it is the 90 degrees because it's lying in the y-axis. So, degrees, 90 degrees. We will put here in the x because it is lying in the y-axis 0. And putting down here, it is negative because it's in the lower part, because this is the negative part of the y-axis. So, on to the next is southwest. Southwest is here, the negative, because it is in the quadrant 3. And for this is south is in the quadrant 4, the positive and negative. So, for us to find or to answer the x and y, here are the formula right there. It is r cos theta. So, what is the r? R is for magnitude, which is here. And this theta is for the degrees. So when it comes to solving it, open your calcu and we need to put first the r, which is 5.5 cos the 0. 5.5 ang lumabas. 5.5. So, here, all you ask is asking why 0? Because it's lying in the x-axis and not in the y-axis. So, it's 0. But, if you try it, it's also the same. So, in y naman, r sin theta. So, r is 5.5. Sin is 0. Equals to 0. So, means 0 siya dun. So, for the number 2, jazz is 8 cos 35. So, 6.55. It round off to the nearest hundreds. So, for the y is 8 sin 35. Change nyo lang from cos to sin, and to y is 4.59. So here, the x is 0 because it is lying in the y-axis again. So, as we you can try it. So, for this, doon na tayo sa y. So, sin 6 sin 90. So, 6 pa din siya, okay? So, for here is rob. So, it's depending on the sign. It's not on the sign here. It's the sign here where you placed it. Don't mind the sign in the calculator. So, 4.5 cos 45 is equivalent to 3.18. And for the sin, just change it. Sin. Oh, sorry. Sin. $3.18. Ay, so sorry. So 3.18 din pala. So for this 9 cos 10 is 8.86. And lastly, for the y is sin. $1.56. So, for us to get the total number of x and the total number of y, you need to add it. So, use the sign. So, negative 5.5 minus 6.55 minus 0 or plus whatever because it's 0. So, minus 3.18 plus 8.86. So, the answer is negative 6.37. 6.37. So, for the x, ganun din. So, 4.59 minus 6 minus 3.18 minus 1.56 is equals to 6.15. So, here are the formula of the resultant vector. So, again, rewrite. So, yan. So, you need to type this on the calcu, which is equivalent to square root of 6.37 squared plus it's negative negative 6.15 square root. So for that you can get the final answer of the resultant vector. So for here, square root again negative 6.37 squared plus negative 6.15 squared. The answer is 8.85. So the resultant vector is 8.85. So as we can see here, it's 8.5. So it's very close. It's still 8 in here to the graphical and component. So it means your resultant vector in a graphical method is accurate. It's right, okay? So how can we get the degrees? So as per the data, here's the formula. So tan -1. So what is the answer? Negative 6.15 over, because it's the equivalent of the x, so negative 6.37. So type in the calcu. You need to shift, click the shift and tan to get the -1. So yeah, type the over. So negative 6.15 over negative 6.37. It's equivalent to 43 degrees 0.99. So it means, so it is equivalent your degrees into 43.99. So what is your degrees in the graphical method is 42. So it's not so far, so it's accurate and it's good. Okay, so here is the degrees. You can put degrees there, and this is the resultant vector. And for the last part is the direction. So as you can see, the final answer here in x and y is both negative. As we can see here in the map of direction, it is in the quadrant 3, the negative part, which is southwest. So we need to take a look. It is in the southwest, where the negative located. So your graph is accurate because here in the component method, the answer of the location is the southwest. So when we write it, r, or the resultant vector, is equivalent to 8.85 at 43.99 degrees southwest. So when we check the graphical and the component method, it's still the same. So your answer is accurate. So that's it for the graphical and component method. I hope that you learned something today. And thank you once again. I am Carl Francis Filipino.